Hi, welcome to Nomis Academy. In this video, we are going to learn the concept of approximation under the application of differentiation. To help us understand the concept of approximation, we need to consider the graph of a curve. Let's take this as the graph of a curve. Okay, and then we have a secant line. The secant line is a line that cuts a particular curve at 2 points, point A and point B. Also, we have a tangent line at point A. This is a tangent line at point A. Okay, at point A, we can trace that to the x-axis. I'm calling it A. This is the x-axis, while this is the y-axis. All right. Now, the gradient of the secant is taken as, we use n to denote gradient. Gradient of the secant, okay, let me write it in word. Gradient of the secant AB is equal to delta y over delta x. While the gradient of the tangents at A, at point A, is given as dy over dx. Alright, so the gradient of the tangent at point A is dy dx, while the gradient of the secant line is delta y delta x. Alright, the concept of approximation implies that at the point A, delta y over delta x is approximately equal to dy over dx at the point where x is equal to A. So the slope of the secant equals the slope, or is approximately equal to the slope of the tangent at the point A. So this is the concept of approximation. We are going to be using this idea to solve a lot of problems. Let's pick the first example, example 1. Find the approximate increase in the area of a cycle if the radius increases from 4 centimeter to 4.04 centimeter. Solution. So in this question, we are asked to find the approximate increase in the area of a cycle if the radius increases from 4 centimeter to 4.04 centimeter. All right, the first thing we need to do, we need to get the change in radius. Change in radius, or the increment in radius, which is delta r, is 4.04 centimeter minus 4 centimeter. So the change is 0.04 centimeter. That is the change. All right, we know that the area of a cycle is giving us pi r squared. That is the area of the formula used in finding the area of a cycle. All right, to go further, we can differentiate A with respect to r, and that will be the A over the r, which is equal to 2 pi r. Okay, the a over the r is 2 pi r. That's the derivative. Alright, from the concept of approximation, we agree. Now, in this case, we are going to call it delta A over delta R. So, in the concept of approximation, we know that delta A all over delta R is approximately equal to the A all over the R. Alright, now since we know this, we can as well take our delta R to the other side, since we are asked to find the approximate increase in the area of a cycle, which is delta A. So we can now cross multiply and take delta R to the other side. So delta A is approximately equal to the A over the R multiplied by delta R. Alright, we know what our delta R is and we know what our the A over the R is. So the A is approximately equal to the A over the R is 2 pi R. Then we write 2 pi R multiplied by delta R is what? 0.04 centimeter. So we write 0.04 centimeter. Alright? Then what is R? Of course, we know that the radius of the cycle is R. If the radius increases from, so the initial radius of the cycle is 4 centimeters. So we have our R to be 4. So we can also state it here. R is equal to 4 centimeters. Then the change or the approximate increase in the area delta A is approximately equal to 2 times the value of pi is 22 over 7. In decimal form is 3.142. So the decimal point is 3.142 times R. R is 4 times 0.04. Alright, delta A is approximately equal to the whole of this 2 times 3.142 times 4 is 25.136 centimeter times 0.04 centimeter. Now the final solution is the whole thing will give us 1.005 centimeter squared. So when you multiply the two, you have 1.005 centimeter squared, which is the increment of the area of the cycle, the approximate increase of the area of the cycle. So this is the solution. If a side of a square increases by 0.5%, find the approximate percentage increase in the area. Alright, solution. Okay, the question says if a side of a square increases by 0.5%, find the approximate percentage increase in the area. Okay, we'll start by writing out the formula for finding the area of a square. which is what? If the side is x, and then the area will be what? X raised to the power of 2. So this is the formula used in finding the area of a square in square units. Alright, now we are going to differentiate a with respect to x, and that will be the a over the x, which is equal to 2x. Now to approximate, remember the concept of approximation under the application of differentiation, and that is delta y all over, okay, now we are using a, so we have delta a all over delta x is approximately equal to the a over the x at the point where x is equal to a particular number. But this is the concept of approximation under the application of differentiation. Alright, now we can cross multiply, and then our delta A is equal to, or approximately equal to, the A over the x multiplied by delta A. Now we know our dx to be 2x, so we can substitute that here. Then have delta A approximately equal to 2x the A. Sorry, this is the x, not the A. We cross multiply, so we have the x. So this is the x. Alright, so at this point we must look for the relative increase in the area, the relative increase in area and the side of the square. So that will be, we are going to divide the equation or the expression by a, which is divide by a, we have a here, we also have a here. That means that delta a over a is approximately equal to 2x delta x, and remember a is x squared, so we write x squared. Let's go to the other side. When you cancel, x cancel this, and then we are left with delta a over a, which is approximately equal to 2 the x all over x. So we have 2 delta x all over x. Alright, according to the question, they said the side increases by 0.5%. So our delta x over x is equal to 0.5%, which is 0.5 over 100, which can also be written as 5 all over 1000. Alright, so since we have this, we can now substitute this in this expression. So our delta a over a is equal to 2 into 5 over 1000. So we have it to be 10 divided by 1000. 0 cancels 0. We have 1 over 100. Okay, now we go to answer the question. Find the approximate percentage increase. Approximate percentage increase. So the percentage increase in A is given as the relative increment in the area, multiplied by 100%. Okay, now we know our relative increment in A, which is 1 over 100. So we have 1 over 100 multiplied by 100%. So 100 cancel 100, we are left with what? 1%. So the relative or the approximate percentage increment or increase in the area is 1%. Alright, let's pick the next example. Example 2. Example 2 says find the approximate value of the square root of 25.01. So we are going to find the approximate square root of 25.01. Solution. So at this point, we say let x equal to 25 and then change. That's the x or delta x is equal to 0.01. And then our y is equal to the square root of x. X is 0.01. So the square root of x, we have it this way. Okay? Since we have y, which is the square root of x, we can now say differentiate y with respect to x. First and foremost, write the square root of x in index form. So that would be y equal to x raised to the power of half. Now to find the derivative of the function, we have dy over dx, which is equal to 1 over 2x minus half. Alright, so let's move to the other side. Okay, so since we have dy over dx, which is equal to, you can write it like this, 1 all over 2 square root of x. So dy dx is 1 all over 2 root x. Now the concept of approximation under the application of differentiation says that delta y all over delta x is approximately equal to dy over the x. Alright, so delta y approximately equal to dy dx, which is 1 all over 2 root x, 1 all over 2 root x. Then we cross multiply by delta x. Delta x is 0.01. So we can go further. Okay, we can go further to put in the value of x. So the delta y approximately equal to 1 all over 2 x is 25. 25 multiplied by 0.01. Delta y approximately equal to 1 all over square root of 25 is 5. 5 times 2 is 10 times 0.01. So when you check the value of this with your calculator, delta y approximately is equal to 0.001. Okay, now this is the increment in y. Now the approximate value of the question given 25.01, the approximate square root of 25.01 is 5 plus 0.001, which is 5.001. So 5.001 is approximate square root of 25.01. Thank you for watching. See you next time. Bye.